take something that is kind of inherently qualitative and turn it into a quantitative project. And then, of course, on the back end, you've got all this analysis that you can do, right? So the most basic kind of analysis, most people, they don't know what to call it, so they pretend like it's no form of analysis at all, but it's the most important kind of analysis, and it's the analysis that is using your brain. So that is, you read things and you look at the world, and then you use your brain and think about it and come up with answers. That's the most powerful methodology out there. But because everybody has equal access to it, you don't need, particularly nuanced and complicated training to do it. It's not okay to say in your research methodology section that I applied the thinking strategy with regard to this problem. And so, my advice to my students is always, you've got to find other ways to describe the thinking strategy that you employed. And so there's a game that you play. You say, if I'm writing history, I say that I used historical methodologies and archival techniques. And, what did I really do? I read stuff and I thought. And even when you are employing other strategies, and I'll come back to this experimental poll that we did, you still are not off the hook for thinking about things. So I'll give you an example. In crunching the numbers, one of our research assistants then produced a memo where she explained to us that the effect of looking at the new data made people much less confident in school quality than the effect of looking at standardized test scores, and that there was no statistically significant difference between the impact of looking at standardized test scores and the effect of looking at a whole broader range of metrics. Well, that just doesn't make any sense. She just wasn't using the thinking methodology. And so then we had to figure out why that was, because that's impossible. And so one of the key things that you want to be able to do is not only to have a set of techniques that you can apply to the problem, but to also be able to think through what you expect to occur and why you would expect that to occur, and why you might have a finding that you have. The most advanced qualitative researchers who have the most robust mathematical skill sets often produce the most ludicrous kinds of claims because they don't know how to think through the numbers that are on their spreadsheets. So what happened? Well, it turned out with us that in the very first round of our survey, we asked people to rate two kinds of schools. First, pick a school that, and we did it all in one district, pick a school here in the district that you know really well and give ratings to that school. Then we said, now we're going to randomly assign you a school. A lot of what we were doing for the experimental side of things had to do with randomization. There are basically two strategies you can employ. One would be to carefully select a perfectly representative sample of people, or to have a perfectly representative sample of assigned schools, or you can just randomize, right? Because randomization is eventually going to get you. And so we randomly assigned schools. Well, with regard to their familiar schools, that initial rating, right, where we said, don't look at any data yet, just tell us about the quality of the school. For the familiar schools, people were obviously able to issue ratings, right? They know the school, their kid goes there, or they went there, or it's across the street from their house, or they're friends with the principal. But when it came to the unfamiliar schools, and this is, again, where someone would have to actually use a little bit of brain power to think about it, we dug into the data and we saw that most people had clicked whatever one, I guess, aligned with I don't know. And our research assistant had been coding all of those as a score. Well, you can't, first of all, you can't score those because people were saying I don't know. I don't know is a binary. I know or I don't know, 0 and 1, as opposed to I know a little bit, I know significantly, I know a big deal. I don't know is a different kind of answer. Second of all, we had so many people answer I don't know that when she, in this second round, she knew enough to drop those but she dropped, of the 25 people in the room, she dropped all of the responses that were I don't know, and then conducted an analysis of the remaining people who had actually answered the question. Well, she dropped about 18 out of 25. And the 7 people who had issued scores issued fairly high scores. I think they were just random guesses, right? We had randomly assigned them a school, and that school was not the school, and I went back and checked, was not the school they were actually familiar with. But they had given these very high ratings, and as a result, then when we showed them the new data system, right, their ratings couldn't possibly go up. Their ratings were already very high. And they looked at the new data, and their ratings went a little bit down. And because she had dropped all the initial people from the analysis, when those people issued, fair to middling to good ratings, they still weren't as high as the original ratings issued by the 7 people who had given ratings. Well, you have to know that if you drop 18 out of 25 people at the onset of your study, right, analysis, that you first of all don't have valid data. But second of all, you have to think about, why did they not answer the question? They didn't answer the question because they clicked I don't know, right? And in fact, everybody should have clicked I don't know, which makes the responses of the 7 people who actually did answer the question totally invalid. You can't say, well, there were only 7 responses, but the average was a 4.5. And then all 25 people answered it after looking at data, so we had an N of 25, but the average score was only 2.9, and therefore the effect of looking at the data was responsible for a dip in perception of quality from 4.5 to 3.9, right? You can do that with the numbers. You can say that that's what the numbers say, but if you're not using your mind to think through what's actually going on here, right, you can tell a story that is totally wrong. So what did we do? We dropped that out of the analysis. We said we have no time 1 for those people. But then what we did is we looked at time 1 for the other group, for familiar schools, right? And this is the sort of thing, again, find a methodology. So we looked at time 1 from the other schools, and we tracked difference from time 1 to time 2 to time 3 to time 4 versus difference from time 1 to time 2 to time 3 to time 4. Of course, dropping time 1. I'm not going to go into great detail there other than to say we found a statistical technique to deal with it, and the story ended up being the exact opposite story of the one that this research assistant had tried to tell at the very beginning. And so that danger is more acute in a quantitative situation because it can be easy to start treating things as if they are numbers that are detached from reality. Whereas in a qualitative study, it's a little harder to detach yourself that way, right? Because you are inherently talking about schools and people, and so you're telling stories there. And you've always got to have a story. What is the story of this research? What is the story that I am telling? And that applies to, a lot of my work has been historical, but you've got nothing but data points there in historical archives, for instance, right? You have lots of evidence, but what is the story that the evidence is telling? And so you need to be constantly testing that, looking at telling your story and then looking at the evidence. Does the evidence match the story? And keep telling your story in new ways and keep challenging your story, right? And you can keep conducting falsification tests where you say, well, what if, let me think, what's an alternate explanation? One of the alternate explanations that kept me up at night with regard to that experimental poll was I kept thinking, well, what if it's that we just didn't include, because we didn't include raw standardized test scores in the new data. We included growth scores. And I kept thinking, if we had included raw standardized test scores, maybe perceptions would have been just as low, but we excluded that, and so it wasn't a fair comparison. And so I was haunted by that, right? And I kept coming back to the evidence, looking at the evidence. Is there any way that I can show in the evidence that that is not the case? And in fact, there was a way that I could do that, because what we found was that the ratings that people had given to their familiar schools perfectly matched when those schools were randomly assigned to people, to other people, right? So let's say that Joseph says, I am familiar with George Washington High School. And I'm not familiar with it, but I get randomly assigned George Washington. Well, if Joseph is familiar with it and he looks at some data, and it didn't matter actually what set of data that the familiar people looked at, they issued an average rating of something like 4.2 to this school. And when people were randomly assigned that school, if they got the new data system, they gave the same rating that the familiar people did. But if they got the old data, right, the state data, the standardized test score data, they give a much lower rating. And so because they matched, because the familiar people scores from both groups, the standardized test scores and the new data, matched with the group that had looked at the new data, we were able to say, actually what the story here is not that if you take away standardized test scores, people's perceptions will go way up. It's actually that if people have an intimate familiarity with a school, if they really get to know a school, then they're not going to talk smack about that school. But if you, well, unless it's a terrible school, but how many terrible schools are really out there? You know, not many. And so we were able to then say, you know, this thing that kept Jack up at night is not really a concern. So again, the test there is you want to keep telling yourself a story and tell yourself the most aggressively negative version of, you know, be your worst critic. Be that sniper who sits in the back of the audience and asks that mean question, and be that person for yourself, and then keep coming back to your evidence. And the truth is that sometimes the sniper is right, is that you're wrong. You have missed something. You have overlooked something. You have been convinced by your own narrative. But a lot of times there's a way to find some evidence to, you know, to back up the story that you're hoping is true.
So, what do you see yourself doing in the future? What is your future research leading you to at this point?
Expanding the work that I've been doing. I've been working in one district. We've built this alternative accountability model. And so I'm working now with 8 districts to try to scale up that project. So right now we're seeking state support and an ESSA waiver in order to do this in Massachusetts. So there will be lots of research that comes out of that.
Okay. So, quick, actually, kind of to go back to what you were saying when you were ending before. So you have the sniper that finds the hole in your story, and they are correct. What do you do?
You change what you're saying. It happens that you will find evidence that undermines the story you've been telling, and it takes more time and more work, and there is nothing you can do about it because it is more important to be right than to be quick. And so, you know, that happened with us a few times on this project that I've been telling you about, where, you know, we thought we had the story down, and then we looked at the numbers again, and it didn't really hold up. And usually what it means, there's a kind of Occam's razor in reverse here, right? Occam's razor says that